are now on block 4. Oh, welcome back, llamas. We are now on block 4 of topic 10, page 321. I'm actually going to be jumping around from problems today just because I'm a good teacher and I didn't want to jump around. So we're going to learn about a new word today, and that new word is mean absolute deviation. And that is a very long word to have to define. And math people are lazy, so they don't like writing that word all the time. So a lot of people will just call it mad. So if you ever see a problem that says find the mean absolute deviation, or it just says find the mad, it's talking about the same thing. I can't really define mean absolute definition until we solve one, and that's how I know how to define it. So what I want to do is jump to problem 6A. And you have a whole page here. The first half of the page, we're going to write the steps for finding mad. You might want to highlight this, star it, something, because you will want to find this. Steps for mad. Don't write super large because we're going to show our work underneath this. Mad.
I never knew there was a Oh, I thought you said mad.
Steps for mad. We're just going to write them and then we'll talk about how they work in a minute. So the first step, step 1, is to find the mean. And what is mean? What does mean stand for?
It's the average.
It is the average. Could you be any more noisier on my video? Step 2 is to find the distance each point is away from the mean. Then the last step, 3, find the mean of the distances. So 3 steps. It's kind of coincidental that they call the abbreviation spell MAD because quite frankly, calculating MAD makes me mad. Because you do a lot of work, it's easy work, but it's a lot of work just to end up with one measly answer. It's like if I had this big, huge problem taking up my whole board, and then I finally solve it, and I get the answer of 2. And I'm like, really? I did all that work just to have 2 there? And so it's kind of annoying, and you will see why it's annoying. Anyone still writing this? Because I have to clear my space so I can have more room to write.
Is that a problem?
There is.
Like always.
She's recording.
Okay. I need more space. So underneath your steps, you're going to write your example. You might want to circle those steps, highlight it or something. You need need to know those for future cases. Now I'm going to follow those steps. Y'all good, boys, or y'all something cool with the calculator or something? Alright, so step 1, the step said to find the mean. Mean is taking the average. So adding all my points up and dividing by the number of points. So I see a 2 was used, a 5 was used, 3 7s was used, a 9, 2 10s, and then 2 14s.
Wait, why'd you write 3 sevens?
Because there are 3 X's on 7s. Okay? And I notice I'm finding the average. So I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers. So I'm going to have to divide by 10. So I need to add all the top. You have some calculators in front of you. I need some people to test it. I didn't say top.
How many numbers?
I don't want you to divide it. I want you to add the numerator.
I can do that in my freaking head.
John says 85. What? Anybody confirm that?
Yes.
I confirm.
85?
Yes.
I confirm 85.
All right. I confirm it is 85.
100.
Aiden.
That thing wasn't even on.
It added up to 85. I need to now divide by 10 and I get 8.5 as the mean. I have just done step 1. What I want to do now is, you know, a seesaw at the park. So, a seesaw at the park, it has a base that it's sitting on in the dead center, right? If someone is the same weight, the seesaw is level. If one person is heavier, that side goes down, right? The seesaw, it's we just calculated the mean. So the mean was 8.5. So that means when I have my seesaw, the base of that seesaw is on 8.5. That's the middle. So everyone draw your base of the seesaw. 8.5. So the mean tells me that everybody's weight on either side of the base is equaled out. But are they the exact same? Like, do I have a number 5 the same distance over here on the other side? No. Okay, so the weights are equaling out. So my step, you are getting on my nerves. Step 2 says to find the distance. Each point is away from the mean. So I'm going to take the left side first. Here's that mean. I need the distance away each point. I see this X on 7. That guy is 1.5 away. Agree?
Yes.
But there are 3 guys that's 1.5 away. So I could list 1.5 plus 1.5 plus 1.5, or I could be lazy and say 1.5 times 3 plus, I'm looking at the left side, this guy here is how far away from the mean? That 5 guy is 3.5. Then this 2 guy is how far? 1, 2, 3, 4, 5, 6.5. And that's everybody on the left side, correct? So I'm going to total that up. 3 times 1.5 is 4.5. 4.5 plus 3.5 is 8. 8 plus 6.5. I get 14.5. That's the left side, and that's how much the weight is on the left side. Looking at the right side, this 5, what's his distance away? 0.5. Then I have a 10. How far away is he? 1.5. But there are 2 people sitting on 10. So times 2. Then I have the guys over here on 14. How far are they? 5.5. How many of those guys do I have? 2. So I need to see what this side weighs. 14.5. Well, does it make sense that both sides are the same value?
Yes.
Since my seesaw is even straight across from my mean, both sides have to weigh the same. So this part should confirm that you did your mean correctly. Now step 3, it says to find the mean of the distances. Number 2 is where we found the distances. Mean is average. So I'm going to add up 14.5 plus 14.5. And I'm going to divide by the number of people on the seesaw. How many people are on the seesaw? 10. So 14.5 plus 14.5 gives me 29. Then 29 divided by 10 gives me 2.9. That is my MAD number, or my mean absolute deviation number. So all of that work was required just to get 2.9. Now let me tell you what the MAD value, or the mean absolute deviation, stands for. If this number that I get is low, like between 1 and 4, 5-ish, if it's in between that area, that means most of my data points are going to be close to my base of my seesaw. If I got a number like 12 for my MAD value, that means I have some people sitting at the very ends far away from my seesaw. They're spread out more. So since this is kind of low, it's saying most of them are in very close to the base of my seesaw. If I got a MAD value of 0, what would that tell me? Everybody is sitting on the mean, or the base of the seesaw. That would mean everybody is lined up there. If I got a MAD of 1, that would mean probably everybody is right there by the base. And if they weren't, I might have one person out here and everybody was on the base, is the only reason it would change it. So that is what our MAD, or mean absolute deviation, tells us. So I want to jump now to number 1. John. Get up. Number 1. We're going to look for another MAD value. However, number 1 was being nice. Why were they being nice? They already gave us, step 1, the mean. So what is the mean?
5.1.
5. It's 5. It might look like it's a hair off, but it's 5. I'm going to go with 5. That is our mean. So now I can go ahead and jump to step 2, finding the distances. Well, what's the distance of these 2 guys sitting on the base? 0. So do I need to write a plus 0 right here? No, I could, but I don't have to. So how far away is this guy? 1. And the 2 guy? 3. And the 0, guys, is how far?
5.
5, but I
10.
have 2 of those, that's 5 away. So that gives me on the left side a grand total of 14. The right side, I have a person that is 2 away. Another person is
3 away.
3, 4,
5.
and then 5.
14.
And that is also 14. Are they equal?
Yes.
So my seesaw's equal, I'm doing good. Now step 3 is finding the average of those two distances. So 14 plus 14. How many people are here?
12.
Huh? How many dots are listed?
10.
10. 10. So 14 plus 14 gives me 28
Yes.
divided by 10, 2.8. So my MAD value is 2.8, meaning they're not very far from the base.
Did I keep saying something wrong?
Oh, I forgot to tell you that number 2 was kind of in your way there. I'm not doing number 2. You can scratch number 2 out. Number 2 had us doing like 75 numbers. So I had to sit there and do 75 numbers to find the MAD. And I don't want to do that, so I'm not going to make us do that.
Thank you.
I'm pretty big on if I don't have to do that, then you don't have to do that. So I will tell you that I did do number 2, number 2 first hour, because I forgot I didn't want to do it. And I did the whole problem, got to the very end, and I realized I forgot a number in my very first step. So I did 75 of those numbers and messed it all up for the very end. And guess what? I did not redo that bad boy, because that was a lot of work and I was very mad. All right. Now I want to look at number 3. So number 3, we take our test on computers, correct? Yes. So, I've been making you draw a box and whiskers, create line plots, create frequency tables. Do you think if I'm taking those on computers, am I going to be able to construct those very well to submit an answer? Most of your test questions are going to have the graphs and plots already done for you. You just have to answer questions about the graphs. But to know about the graphs, you had to know how they were made. So that's why you learned how they were made. So these are kind of like test questions. They're not making us draw anything, we're just answering questions about the graphs. So the first one says the majority of the students responded that they would use the track less than 6 hours per week. I don't want to know if it's true or false yet. I want to know which graph would help you answer that question. I have a frequency plot, a line plot, and a box and whisker. Which is the one that is going to tell me the best about that answer? I hear some people saying line, some people saying box and whisker, some people saying frequency. Frequency, I would say, would be the least likely to use. I would assume 7th graders would want to use a line plot because they understand it the best. However, box and whisker is the easiest to answer this question. It says using the track less than 6 hours per week. Yesterday I talked about what each section represented of the box and whisker. What did it represent? 25%. So I can quickly see that 6 and below has what percent of the data? 75%. I could have found that from my line plot, but I would have had to do a little more calculation than just glancing at it. I would have had to test and make sure there's more points below it. But glancing, I can see 75% of the data is below 6. So the majority of students responded less than 6 hours per week. Is that true or false?
True.
That is true, because 75% was the majority.
So these are all true and false.
Yes. The next question, again, I don't want to know true and false yet. I want to know which graph you would use. 5 students responded 8.5 hours per week. Which one would help me answer that question?
All the way.
All the way, or frequency table probably too, because can't you see if 8.5 is even listed?
Yes.
It's not even listed, and I don't see 8.5 listed in the line plot either. So is this true or false? That would be false for sure. Yesterday, I taught you what interquartile range was. Interquartile is your 2 lines of your boxes, outside lines. Range is your distance they are. So what is my interquartile range of? It's between 1 and 6, which means the distance is 5. They said the interquartile range is 6 hours. Is that true or false? False. You have something you need?
Oh no, I thought my best friend here was Sal. No,
Okay.
no, he's good. He's good, Reg. We gotta watch out for my brothers.
Hey, what?
Hey,
Hey, what is it?
you know what I mean?
The last question says the most frequent response was 0 hours per week. Which one would be the best and quickest way to answer this question? Line plot, because that tells me most popular, so obviously, is that true or false?
True.
That is true. I think he feels the same about you. And you like,
She needs to find a picture.
okay? I want to go to 5 next. Last one on that top number. Quiet. 5 says to look at the 2 graphs. I have one graph from week 1 of time spent working on homework, and then week 2 of time spent working on homework. They both say the mean is 5, so they already calculated the mean. Do they both have the same exact points? No. Eddie, can you focus? It's kind of hard when you can't look at the points. Do they have the same points? No. But they have the same mean. The only way I know how to explain this is, can 2 people have the same exact grades,
Yes.
but score different on some assignments? One person might have scored a C on everything that they took, every test and every assignment, while another person could have made an F on one test, an A on another, an F on one, an A on another, and it's computing to a C. Stop. Who the frick cares? You're interrupting. So, this person that had straight C's, obviously, what are they going to have on their report card? A C. All the data is real close. This person had a lot of the same score grades. Then you have a person that fluctuates, have really high and really low grades, has an A, F, A, F, A, F, and it ended up being what average? A C as well. This person had a lot of low grades and a lot of high grades, and it averaged out to be the same grade. Does that make sense how they both have the same mean? Okay, we don't need to write anything. I just wanted to talk about it. I want to go to 7. We're looking at the height of girls in the class and the height of boys in the class. And A says, which group appears to have a greater average height? The girls or the boys?
Girls.
Greater average height.
Boys.
The boys have more people that's taller, so that's making our average start meeting in the middle about right there. The girls starts meeting in the middle about right there. So who has the greatest average height?
The boys.
The boys, because 5 of the kids total are bigger than 64 inches. When the girls, they only had 2 that even reached 64 inches. So it was definitely the boys. B said, B we have, you all still writing? B, we're learning a new vocabulary word, and that word is variability. Might want to write this. Variability means the spread of the data. We talked about spread yesterday. How they're dispersed. Says which group appears to have the greater variability in height. So which one has the greater spread amongst the data? The boys, the girls kind of gets clustered right in here, where the boys is kind of more evenly dispersed. So we're going to say boys has more variability or spread. Girls is more clustered. Sounds about right. Girls kind of cluster up and get all
In drama
and stuff. Boys just kind of spread out, do whatever they want.
Look at them.
Who has no friends?
It's my favorite. Not me, dude. I'm literally the most famous person in this class.
I'm pretty sure I have more followers than you.
Oh, really? How much? I have more followers than you.
What are we talking about?
Aiden, Gibby has more.
I have more.
So do I.
Hey.
He has a polar bears in Antarctica.
You're writing.
One.
You're writing.
It goes.
I'm ready.
I don't know if we're laughing.
Hush. Excuse me. Recording here.
Hey, Lance.
Oh, but I say that.
Yeah, because I don't like you. Just kidding, I'm best friend. We can do that because we're friends. I did number 7. Circle 6B. This is the only problem I'm requiring you to work for homework. You have to calculate the MAD value. However, pay attention. How many numbers are going to be listed total? What? 1, 2, 7. There's only 8 X's. Our last 2 problems we divided by 10 because there were 10. So this time we're having to divide by 8. So you have the example right next to it. Calculate your MAD value, and then you'll be done for today and not have homework.
I believe my math
Thanks for listening. Like, subscribe, hit the notification bell, and
Peace out, home dogs.
I was trying to waste like 10 more seconds so I could end it right on 30. And peace out, home dog or llamas.
We're gonna end it at.
Can I plug, please?
Peace out.